Have you ever wondered how a resistor works in an electronic circuit? Well, it all comes down to a little thing called resistance. Picture a highway with multiple lanes. The more lanes there are, the smoother the traffic flows. But if you reduce the number of lanes, traffic slows down. That's essentially what a resistor does in an electronic circuit. It's a passive device that restricts the flow of electric current, much like reducing the number of lanes on a highway. Resistance is the property that determines how much a resistor restricts the flow of electricity. It's measured in a unit called ohms, represented by the Greek letter omega. The resistance of a resistor is determined by its material length and thickness. Just like how a longer, narrower highway with rougher surfaces would slow down traffic more than a shorter, wider one with smoother surfaces. Now, how do we calculate this resistance? That's where Ohm's law comes into play. Named after the German physicist Georg Simon Ohm, this law states that the resistance is equal to the voltage across the resistor divided by the current flowing through it. In other words, if you know the voltage drop across a resistor and the current passing through it, you can calculate its resistance. Resistors come in all shapes and sizes, but the most common type is the fixed resistor. As the name suggests, these have a set resistance value that doesn't change once the circuit is designed, but there are also variable resistors that allow you to adjust their resistance through a movable element or slider. To wrap it all up, resistors play a crucial role in the world of electronics. They manage the current in electronic circuits, ensuring that each component receives just the right amount of power. They also protect these components from damage by preventing excessive current flow. So the next time you're tinkering with an electronic device, remember the humble resistor, silently doing its job to keep everything running smoothly.